And by the way, Aristotle wasn't the first to fundamentally disagree with his research advisor. So let's come down to earth and consider the extremely human skill of grasping and manipulation. Humans are incredibly good at this. And it's unfortunate, but currently the state of the art is robots are not. I've been working on this problem for 35 years, and we've made, I have to say, regrettably little progress. But it's important because if we could address this problem, if we could get robots to be able to pick up arbitrary objects, we could send them out to clean up our homes, our rooms, our offices. And of course, also, we can put them to work in warehouses. Because there, we have an immense variety of different objects that have to be put together into boxes, and very rapidly. So Rod Brooks, who's here, very recently posed this as a grand challenge. That if robots could obtain the ability to grasp arbitrary objects, that this would have a tremendous impact in homes, factories, and warehouses. Now, I don't believe that the answer is going to be with much more complex hardware. And this is an existence proof. If you look at the Da Vinci system that's used for robot surgery, very, very simple manipulators, just binary grippers, are able to do very, very complex maneuvers. And so the problem is not in the hardware. It's actually in the perception and the control. Now, the perception, we have made advances, and you're probably familiar with LiDAR. It was recently announced that LiDAR is the secret sauce of autonomous driving. And it can be applied, or structured lighting, its variant with lasers, can be applied in the warehouse. So if you see a pile of objects, like you see on the left in a bin, this is what it looks like to the LiDAR system. So this is a three-dimensional map of points in space. Now, I want to point out that this is not a magic bullet. The data is actually quite noisy and imprecise. Because of specularities, if there's any transparency in your objects due to packaging or other things, or even roughness, those points will actually get missed. And so you'll have gaps and noise and errors in the LiDAR data set. There's also something fundamentally else going on when you're trying to do robot manipulation. And this has to do with the physics. So it turns out we can predict the motion of an asteroid 1 million miles away much better than we can predict the motion of an object that we push across the table. So here's an example. This is a robot. I programmed it to just push this object, the same initial conditions, the same motion of the robot, but you see that the outcome in each case is dramatically different. And the reason is because of the fundamental surface properties, the micro-friction that's going on. So if you put 1 grain of sand underneath that object, it's going to behave very, very differently. And so this is important to note that the physics, it's not just a matter of getting better models of this. It's fundamentally, the final position of this object is fundamentally undecidable. By the way, I think this may explain